So assignment 6.4 by Sam Marsh. Notational analysis tests 1 and 2. In test 1 we instructed our clients to stand just behind the free throw line and complete 10 jump shots. We recorded the results, indicating that the performer must jump in order for it to be counted as a valid shot if it went in. If they did not jump, shooting a typical free throw, then the attempt would be voided as a miss. By completing this test, we could see the client's pure ability to shoot a close jump shot skill without a defender. Any mistakes were noted as an unforced error. In our second test, the drill was the same as drill 1. However, a defender would be present to try and defend their shot. We asked the defender to stand on the baseline, in which they would then turn around and pass the ball out to the shooter. When they received the ball, the defender would run at the shooter. This was done to identify if the presence of a defender had a larger impact on their jump shot when it's an open skill and influenced by its environment. We allowed the shooter to take a step to the side to allow them to generate the highest chance of them converting when shooting. We noted down that the results using a table and converted them into a graph, which sufficed our notational analysis. Our third test was a rebound test. We asked the performer to stand under the hoop whilst an administrator stood on the free throw line. They would then proceed to shoot the ball at the backboard in different places each time, recreating a shot, in which the client would then turn around and rebound the shot. In order to understand what makes a successful rebound, we set a performance criteria that they had to jump whilst rebounding and making sure that they catch the ball before it hit the ground. By doing this uncontested, it was a close skill to an extent. The next notational analysis test we completed was another rebound test with the same method as test 3. However, this time we had 2 people competing for the rebound on each shot, representing a game scenario. As a result of this, the skills changed from a close skill to an open one, and any errors were from unforced to forced, as the performers would appeal to the performance criteria of boxing each other out, and thus was harder to complete the rebound. If nobody successfully caught the ball, then the attempt was not counted on our final results. So here is some raw data from the jump shots, rebounds, take-high jump mat and height. So, uncontested jump shot against height. The data in the scatter graph suggests that there is no strong correlation between the height of someone and how many jump shots were successful. I worked out that there is a correlation between the two of 31.8%, which needs to be 50% to suggest there is a positive correlation. Ben, standing at 190 cm tall, made 2 out of the 10 jump shots, so 20%, missing 8, whereas Jade, 162 cm tall, made 3 of her shots, missing 7. At this level, our scatter graph suggests that height influences little on the conversion rate of total shots, suggesting skill may be of a higher influence. The scatter graph shows that once again, the correlation of 37.8% is still too small to prove that there is a correlation between height and the amount of successful shots when they're being contested by the defender. When shooting under pressure, Ben missed 80% of his shots, scoring 2, whereas Jade missed 70% of her shots, scoring 3. This suggests that height had limited influence on the conversion rates of shots when contested and uncontested. In relation to averages, Jade is above average for uncontested shots and is significantly higher on her contested shots made, 33.3% more than the average, despite her height being significantly smaller, 162 cm, than the class average of 175 cm and a gender average of 166.2 cm. Ben, on the other hand, is much taller, 190 cm, than the class average and gender average of 183 cm, but is below average on successful shots both uncontested and contested. This further proves that there are no significant correlation between height and shots made. However, experience and technique are massive factors when shooting jump shots at this level due to the clients having limited skill. This scatter graph suggests that in the 10 shots taken, there is a 14% correlation between how high someone can jump and the success rate of their uncontested jump shots, and a 26% correlation between someone's success when being guarded and take-high jump mat. Due to neither having a significant correlation of over 50%, we can prove that technique is more important at our athlete's level. In the uncontested, jumping 49 cm, Ben made 2 successful jump shots, missing 8, and 2 successful shots in the contested situation, also missing 8. On the other hand, Jade made 4 successful jump shots attempts when uncontested at jumping at 44 cm, missing 6, and 3 when contested, missing 7. The lack of correlation and conclusive evidence suggests that jumping height had little effect on the amount of baskets made, and coupled with the lack of influence of height, confirms that technique is the biggest factor at our client's level. They should look at this via a technical model and compare it to a literature on an elite athlete. In relation to averages, Jade is below average on her take-high jump test, which is 44 and the average was 48, but higher than her gender average, which was 41.6. She shot higher than the class average without a defender, scoring 3, and also when a defender was present, also 3. Ben scored 49 on the take-high jump test, above the class average but lower than his gender average, which was 53.6. He shot slightly below the class average on the uncontested jump shot of 2, and then the unpressured shot, which was also 2. Due to them having similar scores, despite the massive difference in take-high jump height, we can conclude that the success rate and jump height do not have a significant correlation, 14 and 26%. As a result of this, if they best wanted to improve, they would need to improve their technique, in which can be achieved by using a technical model to analyse your jump shot compared to an elite athlete, literature or combination approach. Jade may want to also increase the height of her jump as in relation to the average, so significantly below to reduce the distance the ball has to travel between basket and height of release. This data shows that there is a weak correlation of 34% between the factor of height and how many rebounds were won in our clients. Ben, standing at 190 centimeters tall, and Jade, standing at 162 centimeters, both rebounded 8 times successfully when uncontested. This suggests that height is less of a factor when rebounding, and as both scored around average results on the take-high jump mat, they may want to look at their technique via the technical model to improve. Similarly to the uncontested rebounds, there is a 23% correlation between the height of the person and the amount of rebounds won against another client. Ben, of 190 centimeters, went against Oshin of 185 centimeters and won 4 of them. Jade, on the other hand, standing at 162 centimeters, was smaller than her competitor Evelyn of 171 centimeters, and she won 7 rebounds, further proving that technique and anticipation are far more crucial in the level of competence in our clients. If each of them wanted to improve their score, then they would need to look at a technical model. In relation to the averages, Jade is massively below average by approximately 12 centimeters on class height, yet made 8 rebounds, above the class average of 7.4. She also scored 7 contested rebounds, which is above the average of 4.9. Ben, on the other hand, is significantly above average height and managed above average on the uncontested rebounds, so 8 better than 7.4, but below average on the contested rebounds, 4 worse than 4.9. This proves that technique is the larger issue here, as we would expect someone who is the tallest in the class to have made the most rebound. However, it must be taken into consideration who they competed against, as different personality types will influence the extent the clients attempt to rebound over one another. We can conclude that the higher the take-high jump score, the more rebounds were caught due to an 82% correlation. This may be due to when the participants jumped, they reduce the potential distance that the ball is able to move, allowing them to catch it when it originally hits the backboard and travels in a direction. Jade scored a below average score in terms of the take-high jump mat of 44 and rebounded 8 times successfully, missing 2. Ben, on the other hand, scored an above average score on the take-high jump mat of 49, yet scored the same result as Jade. Whilst this doesn't show a correlation like the rest of the data, we can conclude that perhaps technique is of a higher factor if Jade managed to score the same result despite having an inferior jump mat score. The height jumped on the take-high jump mat and amount of contested shots won have 0 correlation of minus 12%. Ben, scoring a result of 49, only successfully won 4 rebounds, whereas Jade, scoring 44 on a jump mat, managed to rebound 7 times against her competitor. We would have expected Ben to score more than Jade due to his physical advantage. However, perhaps due to a lack of technique in boxing out, he was unable to perform as well as compared to Jade. For him, we can look at a technical model to improve, whereas Jade, we can look at a numerical model to increase her score. In relation to the averages, Jade scored significantly lower than the class average on the take-high jump mat of 44, less than 48, yet scored above average on both uncontested and contested with scores of 8 and 7 rebounds. Ben, on the other hand, scored above average on his take-high jump mat of 49 and slightly above average on the amount of uncontested rebounds he made, 8 better than 7.4, yet lower than the contested rebounds of 4, worse than 4.9. This data further proves that there is little correlation between the two figures, which results mostly depending on the factors such as technique and determination. As said before, if Jade wants to increase her score, she will need to increase her take-high jump mat via a numerical model, and Ben would have to increase his technique via a technical model. For the technical model, we'll be using literature and elite level comparison in an attempt to identify incorrect techniques within our clients' jump shots. From here, we can see that what they're doing differently from the literature describes and what the elite athletes were performing, and then make changes to improve their performance. However, it must be considered that in these videos some angles may be incorrect due to a lack of expert specialist equipment. Whilst these angles are fairly similar in the height of the camera having enough vertical scaling to see the actions of each athlete's body, there are some problems. For example, the horizontal scaling was not large enough so we cannot see if the ball actually went in for Jade. However, this may not be as a problem as we perform notational analysis. Furthermore, it must be considered that the camera quality has been hindered when transferring videos over, so exact angles on the technical analysis may not be totally accurate. So, as per instructables.com, the literature for a jump shot are: your feet should be shoulder width apart and facing about 10 to 45 degrees towards your non-shooting hand or the support hand, allowing your body to be aligned with the basket. The knees should be bent to allow a firm base and a nice cushion to be able to jump when you shoot. You should spread your fingers and hold the ball with your fingertips to get as much control on the ball as possible, whilst positioning your shooting hand, your dominant hand, behind the ball so that the back of the hand faces directly away from the basket. When the upper part of the shooting arm is horizontal to the body, the elbow and wrist should be at 90 degrees. In the execution phase, you should bend your knees and jump, pushing your legs up and shooting your body straight up in the air. As you jump, you'll want to keep the shooting arm in line with the basket, as you should think of the shooting arm as a catapult. The arc that you get on the ball is very important. Too flat of a shot makes the basket a much smaller target to hit, while putting too much of the arc on the ball makes the shot a much more difficult shot due to the extra strength it needs. When you have reached the top of your shot and the shooting arm is almost fully extended, flick your wrist forwards towards the basket to shoot the ball. The extension of the arm is the power of the shot, and the flick of the wrist as a movement forward that carries the ball to the basket. The non-shooting arm should follow the ball all the way to the top of the shot and then simply let the ball be guided by the shooting hand for the shot. After the release and the recovery phase, you should carry through with full extension of the arm and hold it there until along with the non-shooting hand until you reach the ground. Jade has some differences in technique to the literature and elite athlete, which may have been the cause to her 7 unforced and forced errors. At the beginning of the video, she does not have her feet shoulder width apart, whereas the elite athlete does. This means her base of support is narrower and thus will hinder the distance and trajectory of the ball. She cannot jump up as high, which is vital for her to do considering her below average take-high jump score. Despite this, similarly to the elite athlete, she does bend her knees, allowing her to jump up and shoot the ball. She has both hands on the side of the ball and is prepared to shoot it as if it were a chest pass, not having the elbow and wrist of the shooting hand horizontal to the body at a 90-degree angle like the elite athlete. This will increase the chance of it hitting the board and flying back out due to an increase in power along the horizontal plane with a lower angle of release below the head, rather than the vertical height and release above the head. When using a biomechanical review, we can identify that at the preparatory stage for each athlete jump, the elite athlete has an obtuse angle of their leg of 120 degrees approximately, whereas Jade is about to jump with her leg straight at 180-degree angle. Furthermore, as said before, the elite athlete has his shooting hand at a 90-degree angle horizontal to his body, allowing the ball to be positioned above his head so he can achieve the necessary arc. Jade has hers at approximately 70 degrees below her body, meaning the angle of release is lower and thus her ball will travel across her horizontal plane, reducing the chance it goes in as a lower height of release. This may have been the downfall for a contested shot, as she needed to loop it over the defender to score. She is the basic of jumping forwards when shooting, but needs to focus on elevating her arms above her head, enabling her to increase the range and correct amount of power on her shots. Similarly to the elite athlete, our client continues to make eye contact with the basket, allowing her to increase her shot accuracy. Unlike the elite athlete's video, the basket is not in sight as a result of poor horizontal scaling, so we cannot infer if her shooting arm was aimed towards the basket at all times. Due to incorrect shooting positioning, she pushes the ball outwards rather than the preferred angle of 35-37 degrees, whereas the pro keeps his arms above his head and shoots it up, increasing the size of the target for the ball to go in. Unlike the elite athlete, it appears she does not flick her wrist after releasing the ball, reducing its accuracy. These differences in technique and her below-average take-high jump out score may have been the reasons for her low, yet above-average shooting scores. Jade doesn't straighten her arms as she shoots, instead using her arms as the main power source, which may be a large reason as to her push technique.